Welcome to our competency-based question series designed chapter-wise to strengthen your conceptual learning and
Question 2. It says that P and Q are two identical charge particles of mass 4 into 10 to the power minus 26 kg and charge 4.8 into 10 to the power minus 19 coulomb. Both of them are moving with a speed of 2.4 into 10 to the power 5 meter per second. We can write the velocity for charge Q. It is towards the positive x-axis. So VQ vector is VQ vector magnitude into I cap. And VP vector, the velocity of charge particle P, it is towards negative x-axis. So we can write VP vector is magnitude of VP into I cap with a minus sign. It is towards the negative x-axis. They both are at a distance of 1 meter from each other. And when they are moving, a magnetic field is switched on such that the two particles undergo head-on collision. It means as soon as the magnetic field is switched on, a force is applied on both of them, and charge particle P, it has started moving along this trajectory, and charge particle Q, it has started moving along this trajectory, and they may have a head-on collision somewhere at this point. So for the head-on collision, force on charge particle Q has to be in upward direction, and force on charge particle P has to be in downward direction. So we know that the magnetic Lorentz force F, it is given by the formula Q V cross P. Since both of these charge particles, they are having positive charge 4.8 into 10 to the power minus 19 coulomb, the sign of Q is positive. We can find out the direction of magnetic field B by taking the force on either of the charge particles. Here I am taking the force on the charge particle Q. So F Q vector, the force on charge particle Q, it is magnitude of FQ multiplied by J cap, as the charge particle Q is moving in the upward direction. So this equation will be in such a way that the cross product of the velocity of the charge particle Q along with the magnetic field has to give us J cap. So it is something like this. FQ J cap has to be equal to Q times velocity of charge particle Q, and that is along the I cap multiplied by V vector. So some unit vector that must be multiplied by I cap, that will give us J cap. So we know this thing that I cap multiplied by K cap, it is equal to minus J cap. So I cap cross K cap is minus J cap. But here we are getting J cap. So this, the direction of magnetic field P has to be along minus K cap. That is I cap cross minus K cap is equal to J cap. So we can say the direction of magnetic field is along minus K cap, that is perpendicular to the direction of velocity of both P and Q and going in the plane, that is across. Now in the second part, we need to find the magnitude of the magnetic field applied in the region. That can be obtained with the formula R is equal to mv upon qb. We know the radius of the circular path followed by the charge particle when they are subjected to a magnetic field. It is given by this formula. mv upon qb. And here, the radius of the path followed by each of the particle has to be equal to half of this height, because the distance between them is 1 meter, and they will undergo a head-on collision when they follow the trajectory on the circular path having radius r is equal to 0.5 meter. So we can use this formula to find out the magnetic field B. So R value is 0.5, Q value is 4.8 into 10 to the power minus 19 coulomb. M value is, M is the mass of the charged particle, 4 into 10 to the power minus 26 kg. And V is 2.4 into 10 to the power 5 meter per second for both the particles. So we can use these values. So B, it is equal to R times Q divided by B is equal to mv upon rq. So this B will go towards that side in the cross multiplication, and mv upon rq gives you the magnitude of the magnetic field. So we can use the values here. B is equal to 4 into 10 to the power minus 26, that is the mass, multiplied by velocity 2.4 into 10 to the power 5 meter per second, divided by 4.8 into 10 to the power minus 19, the charge of the charged particles, multiplied by the radius of the trajectory, that is 0.5. When you solve this out, you will be getting B is equal to 0.04 Tesla. So that is the required magnetic field that to be applied for the head-on collision of the charged particles.
Thank you for now. Keep learning, keep practicing, keep